The second half of Lesson 6 focuses on teaching you about moles and empirical formulas. And moles, the concept of a mole is a very important concept in chemistry, and it's one that is really vital for your understanding chemical reactions. So I want to spend a little bit of time introducing you to the concept of a mole and what that is. All right, so a mole. All a mole is simply a unit of measurement. Okay, so the best analogy I can think of is that 1 dozen is 12 of something. Okay, so if you have a dozen donuts, my favorite dozen of anything, dozen donuts, then you have 12 donuts. If you have a dozen eggs, you have 12 eggs. So a mole is like a dozen, but 1 mole is 6.022 times 10 to the 23rd of something. Okay? So if you have 1 mole of molecules, you have 6.022 times 10 to the 23rd molecules. Or if you have 1 mole of eggs, you have 6.022 times 10 to the 23rd eggs. So just to reiterate, a mole is just a unit of measurement, just like a dozen is a unit of measurement. So if we have a chemical equation, one that you're all probably familiar with, you just may not realize it. So this is vinegar and baking soda forming carbon dioxide and water. So we'll put under here that this is vinegar. This is our baking soda. This is essentially the reaction that takes place when you make your volcano in your, you probably did it in a science fair project when you were younger. So when we're looking at this chemical equation, what this is telling us is that 1 molecule of vinegar plus 1 molecule of baking soda makes 1 molecule of acetate plus 1 molecule of carbon dioxide plus 1 molecule of water. So say we wanted to get out a certain amount of carbon dioxide or a certain amount of water. It would be useful to be able to measure out 1 molecule of each of these compounds. But unfortunately, molecules are very small and they're very difficult to measure out. So the mole is our solution to the problem of molecules being so tiny that we can't measure them out directly. So there's a really important connection between the atomic mass on your periodic table and the mole. So remember, we said that the mole is a convenient way for us to be able to measure out a certain number of molecules if we're doing a reaction. So it's really important to note that the atomic mass, which is always listed on your periodic table. I'm going to write this out, atomic mass. And the atomic mass is simply the weight of 1 atom in atomic mass units. Or, and this is what's important, it's also the weight of 1 mole in grams. And this is what's really, really important, this right here. So 1 mole of xenon atoms will weigh 131.293 grams. So 1 mole of xenon atoms weighs 131.293 grams. All right, so we talked about the atomic mass for one particular atom. So now let's talk about it if we have an actual compound, such as our carbon dioxide that we were mentioning a moment ago. So carbon dioxide, if we're looking at just the molecule carbon dioxide, it's made up of 1 carbon atom and 2 oxygen atoms. So if we were now going to think about 1 mole of carbon dioxide, this would contain 1 mole of carbon atoms and 2 moles of oxygen atoms. So if we wanted to determine the mass of 1 mole of CO2, the mass would simply be the sum of the atomic mass of 1 carbon atom and 2 oxygen atoms. So it would be the sum of our atomic mass for all of the atoms in our molecule. So the molecular weight, we sometimes abbreviate it MW for CO2, would simply be 12 times 1, because we have 1 carbon atom. I'm just going to delete this. Plus, we have 2 oxygen atoms. Each mole of oxygen atoms weighs 16 grams. So we would do 16 times 2. So this is going to be 32 plus 12, which is equal to 44 grams in 1 mole of CO2. So this is called our molecular weight.